It's called CVI, the Computer Video Instrument. It has been created to provide an almost unlimited range of spectacular images for video presentations. In the past, these futuristic images have only been achievable through expensive and complicated digital effects units. Let's now see how easy it is to explore just a few of these dramatic images created through the CVI. Stunning chroma key effects. In a strobe effect with variable speed. Operation is simplicity itself, thanks to full menu control. Use CVI to create an unlimited variety of backgrounds and foregrounds. Draw your own matte shapes on the graphics tablet. Select horizontal mirrors. Vertical mirrors. And position them dynamically. A palette of 4,000 colors is instantly available for subtle or startling colorizing effects. Provocative images with a multitude of applications. This extraordinary communication tool was conceived by none other than Fairlight Instruments. In 1978, Fairlight revolutionized the music industry when they introduced the CMI, or Computer Musical Instrument, the first electronic instrument to play natural and acoustic sounds. Today, the CMI is used by the world's greatest musical innovators. In fact, all of the music on this tape is produced directly from a CMI with no multi-track recording. But let's experiment further. Use the airbrush to draw a moving, solarized foreground. Select a texture or draw your own. Remember, everything you are seeing is generated by the CVI. No feedback. There's full paint facilities too. Drawn images can be combined with all other effects. The ability to draw your own matte shapes means unlimited creative possibilities. What you have seen is the mere tip of the iceberg that is CVI. Only when you have one will you really start to appreciate the endless possibilities for your creative expression. In fact, having your own CVI is a lot easier than you'd think because its low price is also revolutionary. So from now on, every video production you develop can incorporate the visual creativity of the computer video instrument. CVI by Fairlight.
You're watching Sleepcore. Pleasant dreams.
Imagine a world within your computer, a world which you have created, a world of infinite possibilities. Welcome to the world of 3D Construction Kit. Whether you want to devise devilish adventure games set on desert islands, or design the mansion you've always dreamed of, construct a futuristic car for your driveway, or even create a 10,000-seater football stadium and then charge down the pitch, 3D Construction Kit gives you all the tools you need to generate worlds where the only boundaries are your imaginations. Using its simple icon-driven control panel, you'll soon be turning your ideas into exciting new environments just waiting to be explored. Harnessing the program's incredible power is as easy as clicking on a mouse or joystick. Start with a small selection of basic building blocks. Stretch and shrink them until they're the correct size and shape, then move them into place. Then duplicate whole walls with a few clicks on a button as you assemble increasingly complex structures. Everything you do is shown on screen instantly so you can experiment to your heart's content. When you've finally finished constructing your world, you can move around at will, investigating objects from every angle. And complete 3D Construction Kit environments will run independently of the Creator program, so you can share them with your friends. With 3D Construction Kit, there are no limits. Now prepare to take a trip through virtual reality as we introduce a few of its possibilities. Whether you just want to doodle in 3 dimensions or meticulously create alternative landscapes right down to the tiniest details, 3D Construction Kit gives you the power. Techniques which were only available to professional programmers are yours as incentive software unlocks the secrets of its incredible Freescape system. First seen in smash hit games such as Driller and Castle Master. Become the architect of buildings large and small. What does it look like to play at Wembley? Grab your kit and design your own stadium. You'll almost believe you can hear the roar of the crowd. For a more peaceful view of the planet, take a ride on your very own space shuttle. Or sculpt the streamlined contours of an award-winning racing car. With 3D Construction Kit, you're soon up and running. You'd like to invite friends round for a tour of your new house, but there's a problem. They live 3,000 miles away. Send them a 3D Construction Kit model for their computer, and they can step through the door and wander around. And you don't have to worry about them overstaying their welcome. With 3D Construction Kit, you can visualize anything from a room layout to an exhibition stand. Now, hop aboard our helicopter for a trip into the realms of fantasy. 3D Construction Kit allows you to create adventure games which are every bit as polished as ones you find in the shops. Develop diabolical puzzles for players to solve as they pit their wits against yours. The program's simple command language allows you to create sophisticated responses to their every action. Shooting the coconuts didn't help, so let's try the chest. Now, what lies around that corner? The answer's up to you. "3D Construction Kit" gives you the tools. You just provide the inspiration.
Hello, I'm Ian Andrew from Incentive Software. In this short video, we'll take you through some of the techniques involved in creating your own Freescape environment.
3D Construction Kit contains all the commands you need to create your own worlds which you can explore at will, providing you don't walk into too many trees. As with any set of tools, it helps to have an idea of how to use them before you start. We'll be introducing some of the basic techniques, and you'll find further details in the manual. We'll also mention any major differences between versions of the program. This is particularly relevant if you have an 8-bit machine such as a Sinclair Spectrum, Commodore 64 or Amstrad CPC. However, most of the techniques are the same on all versions, so normally we'll just show the Commodore Amiga. Now we've cleared the cliffs, let's start with a plain landscape. We communicate with the program using a cursor. On 8-bit versions, we use a joystick or the keyboard. For 16-bit machines, we control it with the mouse. At the top of the screen is a menu bar which contains all the major functions. To make a selection, just move the cursor over the menu until the correct command is highlighted, then press the joystick button or click with the mouse. The middle of the screen is the window onto our Freescape world. At the moment, there's just ground and sky. Directly below this is a status bar. Its figures tell us exactly where we are in our environment. Next come 2 sets of icons. Those on the left control our viewpoint and whether we walk or fly through our landscape. The ones on the right move us around the environment and change our eye level so that we can look up or down. At the bottom of the screen, the major commands are duplicated from the menu bar. If we want a full screen view of our world, we just click on the test button and the control panel vanishes completely.
Well, that's not very interesting at the moment, so let's start creating. The basic building block is a cube, so let's see what we can do with it.
To place a cube in the landscape, we click on the Create button at the bottom of the screen. This leads to another menu containing all the shapes which are available, our building blocks. Cube is at the top right-hand corner. When it first appears, the cube is hovering in mid-air, as we can see if we walk around it using the movement control buttons. On 8-bit machines, objects first appear on the ground. Clicking on the Edit button, then selecting the relevant item from the menu, lets us move it around. As a shortcut, 16-bit owners can click on the object itself rather than using the menu. Either way, the Edit control panel appears at the bottom of the screen. This contains buttons which will move an object, stretch it, shrink it, or turn it through 90 degrees. If you make a mistake, don't worry, there's an undo button at the far right of the panel. Using these controls, we can shrink the cube until it's only the size of a matchbox, then stretch it until it becomes a flagpole. Even though it's grown out of the top of the screen, we can look up with the view button to see that it's all there. But for our simple building, we need a flat wall. We could go through all those stages again to create a second wall, but a more convenient and accurate technique is to use the copy function. On 16-bit, we're given the option of where our new section will appear in relation to the original. The only restriction is that it can't appear inside another object. We place it to the right, and then use the edit commands to move it to one side to form an alleyway. On 8-bit, selections have to be made from the menu, and the new object appears in a set position. But apart from that, the process is essentially the same.
You're watching Sleepcore, media for insomnia.
I'm Carl Eugene Leffler, and my principal research is telecommunications and virtual reality. I design virtual worlds that are networked and shared by more than one person at the same time. My work is supported by the Studio for Creative Inquiry, Carnegie Mellon University, where I coordinate a research team of scientists, artists, and students. But before discussing my work in greater detail, let's begin to define virtual reality.
By fundamental definition, virtual reality is an interactive, three-dimensional, computer-simulated world that is updated or created in real time. Applications can be fully immersive or desktop variety, as in computer games. To interact with an immersive world, a user needs special equipment, a head-mounted display, and a navigation device. The head-mounted display and navigation devices use electronic sensor drivers that send data to the computer, which in turn creates the world in real time. The sensors mark the position of the user in the world, including their point of view and direction of travel. For example, when the user turns their head, the viewpoint changes.
In addition to designing virtual immersive worlds, I'm interested in how multiple participants can be networked or conjoined to share the same world. And sometimes this network can take place over very, very long distance.
The first technical demonstration of network virtual reality took place between Carnegie Mellon University in Pittsburgh and Munich, Germany, a point-to-point link. In this demonstration, users at each site put on a head-mounted display and shared the same world with one another. Each user had an independent point of view and could manipulate objects.
What good is network virtual reality? Imagine the benefit to long-distance education. Imagine a networked immersion environment which was about ancient Egypt.
Here, an educator could lead a guided field tour, or individuals could conduct independent study, and all without the necessity of actually traveling to Egypt.
There remains a broad range of other disciplines that can benefit from network virtual reality. Consider architecture, medicine, and other forms of scientific visualization. What kinds of worlds are we currently building?
The first world constructed was a container or museum to hold the other forthcoming worlds. And this museum, like most museums, is comprised of galleries. The difference is this distributed art museum can come to you, and the galleries feature virtual worlds. When entering the museum, one is greeted by an agent, a synthetic person with an artificial intelligence. Walking through the virtual museum, one can see galleries with exhibits. One of the first gallery exhibitions created for the museum was the Fun House. Here, we are in front of a mirror, which reveals your computer persona. Users can see other users in network virtual reality, so your computer image is very important. Now we are turning left and suddenly encounter another person in the world. We wave in recognition. Imagine inhabiting a virtual world with a multitude of other users, each with their own agenda. Unique to this project is the exploration of physics in virtual reality. And here the attributes of gravity, velocity, and friction are assigned to a dynamic object, in this case a ball. Moving objects add interactivity to a virtual world, and to ride or attach oneself to a moving object is essential. Here, we are being watched by another user as we extend our hand to catch a ride on a merry-go-round. In another Funhouse example, the user touches the floor of the UFO room and is whisked away on a flying saucer parked next to the museum. Once on the craft, it becomes very interactive, and the user can fly it around.
The most recent addition to the Virtual Art Museum is a new work based on Leonardo da Vinci's flying machine, and here one can pilot the craft over a conceptual terrain. Other areas of investigation include the automobile industry.
A number of worlds were designed for the Ford Motor Company, including a virtual showroom and test driving track. The track features a California ocean highway and mountain scenes. Remember that this is network virtual reality, so one can take friends with them on a test drive.
The Ford worlds are representational of industrial projects. And recently, a consortium has been formed with partners in Japan, the United States, and Scandinavia to investigate network virtual reality for education, teleconferencing, and industrial design. The consortium is also investigating network virtual reality for entertainment and consumer home shopping. And to this end, an entire virtual city is under construction.
This city, like any city, will be comprised of private dwellings, parks, stores, and of course, inhabited by scores of users, each with their own purpose.
Finally, we are designing a number of educational applications to be presented in science museums and in schools. They can be networked with more than one site and shared by many participants.
In the music room, one can perform with friends. One of the instruments is a pentatonic type of keyboard with 3 voices, a full orchestra, a choir, and percussion instruments. This networked environment is friendly and intuitive and designed for people of all ages.
My work then is about designing networked virtual worlds that can be inhabited by more than one person at the same time. But importantly, within these worlds, one can do things such as play music, go shopping, or go to ancient Egypt, or participate in a dynamic teleconferencing session or group design processes. Virtual reality has captured our imagination, and networks will render it accessible.